Good. Okay, we're up and running with the recording. Okay, well, thank you to those who submitted their research assignment, and you're all generally a very good group in terms of the promptness and meeting that time frame. And I must say the assignments were wonderful in terms of delving into a technical topic, quite quickly and grabbing some good information, and then creatively putting something together and presenting that. So I really enjoyed going through them, and you would have got feedback through Moodle. But I did say, so you would have got your marks in there, and congratulations. I did give a lot of high marks due to the fact that there was a lot of good assignments. So I did say that I'd give a few prizes out. So technical rigor, most engaging and most creative putting together. I could have given prizes to pretty much all of you, but I did have to pick a few. And so for one reason or another, I picked them. So Harren has got the prize for technical content. That was for the directional signs and road safety paper that was put in. I thought that was excellent. Nicely captured the way directional signs can influence road safety in a variety of ways, and appropriate directional signs. So that was excellent. In most engaging, we've given 2 prizes here. I couldn't differentiate on the most engaging. So Gemma for the landscaping paper, and the engaging use of Wally in there. So that was excellent. So Wally the Wombat appearing now in assignments. And Stephanie for the barrier types, an excellent one there. Thank you. And then the most creative, again, couldn't split a couple of them. So we're going to give our prizes for both. So Melanie for the roundabouts versus traffic signals, excellent stuff. And Sol for the short stacking at railway level crossings. So as I say, amazing stuff across the board. There were picked a few out. Now, what we will do is upload all of those to Moodle, so you'll all be able to have a quick look and be engaged and entertained and informed by the different videos, the different presentations, fact sheets, cartoons that came in, and it was quite a variety of stuff. So well done to all of you. I'll come back a little bit closer to the end of this session, and I'll run through the next assignment. So this week is actually quite intense for you in terms of assignments, but you've got one at the end of this session, which is a bit of desktop work for that practicing finding issues in designs and then writing up audit findings. So all done at the desktop. I'll show you shortly. We've got a bit of video footage and the like to help you identify things, but it's a sort of desktop-y exercise. It's practice in that picking issues and writing them up. And then after Thursday's session is your sort of real / mock road safety audit, but where you're going to get out on a site near your office or your home or the address you gave us with a design, something they're going to change, and you'll be undertaking a mock road safety audit. But I'll explain all of that again after Thursday's session for that one, and after we hear from Fergus Tate shortly, and I'll go through a bit more of the detail of the desktop one. So maybe Ferg, if you pop up your slides there, and we will, I'll give a little introduction to you. And I do see already in the chat some people know who you are very well, so they don't need the introduction, but I will give a little introduction. If you jump one slide forward, and then we can see a lovely picture of you there. So many of you do know Fergus Tate, who's the technical director at WSP, a consultancy there in New Zealand and across the world. And many of you maybe know him from past roles as well, where he was the lead safety advisor at Waka Kotahi, and consultant before that with MWH and Opus, and a research fellow over at Leeds University, where you got your PhD, I believe. Is that correct, Ferg?
That's right, Ken. Yep.
Yeah. And Ferg's done some amazing stuff, and I always enjoy spending time with Ferg when I'm in New Zealand or working on projects with him across road safety infrastructure, auditing, strategizing, technical standards, and the like. So what we would like to do in this course is get somebody with incredible technical expertise around infrastructure design and road safety to present this topic of the design technical end road safety auditing. Now, I certainly enjoy getting out on these audits, but I always do try to include in my team somebody who has a long history in technical design. Now, I have done a bit of design. I wouldn't call myself a designer as such. I, out and about in a lot of areas. So bringing that team together is an important thing. And so for this presentation, I thought Ferg would be a wonderful person to talk that through, not only from the technical perspective, but from the New Zealand content as well. So I'm going to hand over to Ferg now, and Ferg's got some polls in his presentation. He'll be asking you a few questions. I'll be jumping in with questions. Also, so please write your questions into the chat as we're going. I will feed those to Ferg. So Ferg, you don't need to need to try to concentrate on the chat as well as the presentation. I'll feed those too. I'll jump. I'll appear occasionally and jump in. But please, everybody, pop your questions in. And over to you, Ferg.
Okay. Well, thanks, Ken. I have to say I'm a little bit nervous about this. I've never done virtual presenting before in this way, and also this whole technical area is really huge, and you should be under no illusions that what I've done here is chosen a couple of my favorite topics, which I think come up regularly in audits, and a couple of other things, bits of advice that I give to people when they're auditing. It's by nowhere near the breadth in design or anything like that. And I think that the key takeaway is, when you're working in an audit situation and you come across things that you're not so comfortable with, get somebody else involved. 2 heads are always better than 1. 3 heads are even better. There are, you will never, and I will never be an expert on everything. I mean, for me, one of my biggest weaknesses is traffic signals. I have very little interest in them, and whenever I'm faced with a tricky problem, I get somebody else to help me. So I think it's and things. But the ones that I'm going to look at today are typically around understanding drivers' expectations and what happens when you violate those expectations, and that's particularly in the context of highway curves. I don't know if you know, but in the state highway network, 30% of loss of control crashes occur on what we call out of context curves, or curves that are under 400 meters radius. So that's actually a big chunk of DSIs are related to curve negotiation, whether it's loss of control off-road or head-on. It's on those curves, and also one of the other things that we come across is the crash migration issue that we get. And then looking more in the urban area, I'm looking at design vehicles and heavy vehicle operation. It's probably not as strong a crash relationship as curves, but it comes up time and time again when you're working through the detail, particularly in the design space and things. And then I'm going to give some sort of discussions about things like sight distance, and then the use of prompt lists and common issues that I've come across and that Ken's come across as we've gone on. So I'm going to start off with a little bit of a poll, actually, which I think Ken's going to run. There are typically considered to be 4 stages, I suppose, of road safety audit: the feasibility, the preliminary design, the detailed design, and the pre-opening. And I just, nothing scientific. What do you think is the easiest to do? And I'd be interested in that. So what do you think is typically the easiest audit to do?
Now the poll should have popped up on your screen there. Good, yeah, we can see some people popping in their results. We'll let that run for a minute and people can pop in their ideas. And then we will share the results and we'll have a little chat about it. It's a good, interesting question. And we've been through in the earlier modules there, Ferg, those different stages, talked a bit about sort of what you would expect to receive and the sort of levels of, detail you're given and those sorts of things. But very interested in this, sort of thought of, well, which would be the easiest to look at. Good, we're seeing mostly everybody's got their ideas in. I'll give it 5 more seconds. So we'll count them down. 4, 3, 2, 1. And I'm going to end that. And we will share the results. So what are we seeing there? We're seeing most people seem to be saying that pre-opening stage. And then, preliminary design coming in second to detailed and feasibility stage. So, okay, over to you, Ferg. What are your thoughts on that?
I think that's very much how I see it, because I think when you're moving through that spectrum of audits, it's becoming increasingly less abstract. When you're at the post-construction pre-opening stage, you're really looking for snags, safety issues that are related to stuff you can see on the ground. When you're at that feasibility stage, it's far more conceptual. And actually, I find that the advent of the Safe System Assessment Framework works really, really well in that feasibility. And there's a bit of a grey area as you move into preliminary design, but you're talking about options and concepts. And again, so it's a bit or considerably more abstract than when you're looking at the post-construction. The design, which is where I'm focusing on, and whether that's late preliminary or detailed design, there's a hell of a lot in there. And what you're finding when you're doing your audits is there's a hell of a lot missing. And that can be more or less, but you need to sort of have a broad range of skills around what's going on, and you have to be able to visualize the design, what it's going to look like in practice from the drawings, which takes a little bit of time when people are doing it. One good thing I do find about, though, in design is actually when it comes to writing up, these days I find the design, I use things like the snipping tool. I don't know if you've, and photos in those later stages, you can snip a bit, and I'll show you some examples as we go through, and it's quite easy to actually define the problem quite clearly in terms of what's happening. Sometimes with the design, you've got to be really careful, and I don't know what Ken's opinion on this is, but I've always been very conscious that the road safety audit is not a design check. I'll show you an example a bit later on where you can have a compliant design, but it still sucks to pieces, and it's probably not as safe as it could be. So the big thing always with these auditors we're going through is, what is the road safety argument about the thing that you're seeing? Not that I don't like this, or I don't like that, or it's not in the code. It will have this impact probably on the likelihood or the severity of crashes. And what are those crashes that we're talking about? And if you have to write a 15-page essay about a certain set of events that would finally lead to this crash, you've really got to ask yourself, is it real, or am I talking shit? So I think those are the things that we sort of think about as we're going through in terms of the audit stages, is that at this end, at the feasibility end, you're looking far more at things like Safe System Assessment Framework and getting it right at the start. At the post-construction, you've got that detail. Those sump grates are not cycle friendly, and those types of things. And the design bit in the middle, which is probably the largest chunk, requires a huge range of skills. And you really need to be very careful that you're not trying to do a design check, and that the things that you are identifying have a strong lead to safety.
What on that, where you talked a bit about sort of the abstract nature of some of this early stuff due to lack of detail that would be provided to you as an auditor. How do you go about sort of deciding how much information is enough? I mean, these projects are very complex. They're going to have traffic modeling and drainage plans, environmental plans, cultural heritage plans. And where do you sort of stop, or is it a case by case on that?
I think it's case by case. I think the other thing that's quite key with the audits is I mean, some things have a bigger part, and identifying what's been missing, and maybe even doing the audit in multiple chunks. That's happened before. You know, you get the geometrics, but you haven't got the lighting design or the landscaping design or the heritage design, and you just need to say these things are not present, and we believe that we should come back and have a look when that information becomes available, just to give it a check. So you're doing the bulk of work on the geometry and things like that, or while you're doing it, you're saying, hold on, I like this intersection, but show me your tracking curves, because they haven't been included, and they should be there immediately and things. But things like lighting design often comes later, and you might say, I'll have a look at that when it becomes available. So these, what I've got here is a series of quotes from a 1997 Federal Highways publication, which I think is really, really important. And it talks about how do drivers know what the appropriate behavior is so that they don't make mistakes. And well, these are worth actually reading out to you. I've had the thing about reading shit from slides, but in terms of actually reading out to you, I think these are quite important. And it starts with, generally drivers make fewer errors at geometric features that conform with their expectations than at features that violate their a priori or ad hoc expectancy. So basically, if they're expecting it, they tend to make right decisions. If they're not, there's a higher likelihood that they make poor decisions. And if a road is consistent in design, then the road should not violate the expectations of motorists and inhibit their ability to control their vehicle safety. So again, consistency of design, letting drivers know what's coming and what's appropriate. And finally, consistent roadway should ensure that drivers would be able to operate their vehicles at their desired speed along the entire alignment. And these are three really important concepts, or in terms of the likelihood of drivers making mistakes on a design. And one of the areas where, as I said at the start, which was why I'm talking about this, is what's the likelihood or place where drivers make a lot of mistakes is curves, and in particular curves that are difficult to read, so that they're unexpected, or they might be expected but hard to read, for people to know what's coming, or they're out of context curves. In other words, they are violating those expectations, and there's a higher likelihood. Now, if you think about the curve negotiation equation, you've got E, which is super elevation, and F, which is friction, and they're the resisting forces as you go around a curve that stop you from flying off into the paddock. And the things that are likely to drive you from going around the curve and flying off into the paddock are the radius of the curve and the speed at which you go around that radius. So you've got effectively three determining variables, E, F, and R, that help determine what the safe speed is. And I've just got a question. Of those three variables, which is the one that you think is most likely, or of those four variables, most likely to influence drivers' behavior?
So that poll's just popped up there. So you've got there, yeah, E, F, V in there. It's snuck in as well in the poll, but the R being the curve radius in there as well. So we'll have a look at that. As people are popping that in, so we had a good bit of a chat about in some of the earlier sessions, deceiving roads or visual deceit that a road creates, which is a term that I use a lot. So it's maybe a broader category than just what we're talking about here, but I think you articulated it in far more sort of scientific language back in your previous slide.
Yeah, I think yeah, people don't go out unless they're suicidal to deliberately make mistakes. They don't go out to deliberately do things that's going to kill them. So why do they make mistakes? And when we look at our crash data, the biggest thing that we see in our crash data is typically inappropriate speed. And the question I'm asking is, what made the driver think that the speed that they were traveling was appropriate, given that they're unlikely to be suicidal? And what are we doing to give the right messages to drivers about what? And this is this whole consistency of design and understanding what's going on. And particularly in audit of rural roads, I think that the whole thing of curves is the biggest one. How do we go on that poll, Ken?
Most people saying the radius there,
Yes.
curve radius.
Yes, and if you think about it, drivers can't see friction. They've got absolutely no idea what the friction value of a piece of pavement is on a curve. There's some belief that they can feel super elevation when they're in the curve, but at that point, it's probably too freaking late. The big thing that drives drivers' choice of speed as they go around curves is the radius and how they perceive that radius. And that even changes for given radius. If you have a radius, or a particular radius at the bottom of a downhill grade, it will typically look tighter than if it's at the top of an uphill grade. And that will change the way in which drivers look at speed. So what we're looking at are these three variables, and I'll just go to the next slide, the curves that are difficult to read. This is some data that was collected by a group, myself and Shane Turner, some years ago, of 488 curves. And we were looking at the design speed of these curves. Now, that's the V. If you're thinking about the minimum radius of these curves, that design speed for a 300-meter radius curve could be the design speed as an estimate of the safe negotiation could be anywhere from 60 kilometers an hour to 100 kilometers an hour. So looking at that curve that you're looking at and thinking, this is a 300-meter radius curve, I know what to do, you could get badly unstuck if you think what I should be doing is 100 kilometers an hour, when in fact we're doing 60 kilometers an hour. And if I roll back up to this slide here, this is one of the cases that I was talking about. You can have a completely safe, standards meeting curve, but you can rely solely on friction to make that safe. You can put all your eggs in the friction basket and have use the design for the maximum value of side friction and minimum radius and things like that. What that tends to do is it tends to mean that you've got all your eggs in a basket, which one, the drivers don't understand and can't see, and two, is probably the thing that is least well maintained. And so you're putting, while you can have a conforming design, it may not be a good design because you're putting things in the most risky part. But if I continue looking at this curve data that we were looking at, this is something to do with the mean speed that the sample of drivers negotiated the curves in against the minimum curve radius over the tightest part. Now, what you'll see here is when the curves are out, certainly above 450, 500 meters, they're negotiating those curves at the same sort of speed that you would travel down a straight at. There is no implication in terms of speed. Once you start getting under 450, we're still typically traveling at that sort of straight road kind of speed. It's not until we get below 250 that the negotiation speeds that drivers are choosing is dropping badly. So you've got a bunch of curves in here from 250 to 450, where drivers are treating them very similar to straights, but in this range here, their design speeds could be anything from 100 to 60. So what you've got is you've got curves where the drivers look at them and think, I can do this as a straight, whereas the design may actually be catching them out and things. And in fact, this is the 85th percentile speed. And again, when we were looking at that, this is this is at 300. It's very much clearer going in here. And it's interesting because when the RTA, New South Wales RTA were looking at treatment of curves, their highest priority for treatment and curve easing and asymmetric widening and things is the curves that are in that 450 to 250, might be 200 to 400. It's all a bit floaty, but it's this patch here, because those curves are hard for drivers to read. So if you're coming across designs that have got a lot of those curves in them, you're probably more likely to have a safety problem than if you haven't. So that's the curves that are difficult to read and why. The other thing, sorry, Ken.
I was just going to say, Wayne's made a good comment in there. I think about this skid resistance there, or the surface friction there. It's one that's heavily subject to change with weather as well.
Yep.
So you get that extra variability with it as well.
Yep. It's not the place where you want to put your eggs. You want to be. The other thing that you tend to find is that longer curves, partly because they are longer, so therefore there's more distance over which to have crashes, but the crash rate per curve goes up with length quite substantially, because what you're finding is that where you've got a short curve, you can tend to flatline it a little bit. You can adjust your driving position, and moving from the edge line to the center line and flattening the radius actually works, or you can cut it a little bit. But if you've got a long curve and you make a mistake coming into it in terms of your negotiation speed, you've got almost no chance of correcting yourself without getting into trouble. And so longer curves and curves that are in that 450 to 250, 400 to 200 sort of band, try and stick away from those in your design, because they're the ones that are likely to give you problems. The other one that we get, have you covered this? This is probably lined up with your deceitful alignments, is it, Ken?
No, we spent more time in the deceiving alignments and the like, with see-through effects. That was the particular one.
Okay.
The see-through effects are quite easy to sort of take photos of existing roads. These sort of geometric alignment ones are a little harder to get that photo that quite lines it up. So these diagrams are good.
They're a lot harder in the design space, and you really need to be getting that long section with the horizontal on it when you're doing this. I find the cross sections drive me nuts, but a good long section, particularly a good long section that's got the curb lines on it, and you can see how it's warping and things, that gives you, but not hiding railway crossings in here under these humps, or a horizontal curve beyond a crest. I mean, we're lucky we have edge marker posts, but if you've ever driven a road where the edge marker posts have been poorly maintained, you need to see that road surface to be able to work out what the hell's going on. And a lot of our low volume stuff, people are talking about removing edge marker posts and getting it down. It's actually really quite difficult, because most of your sight distance requirements, and I'll talk about sight distance later on, are all to about a 200 millimeter object height, not the road surface. So unless you've got things like edge marker posts, or worse, you can have things like fence lines and power lines, which are actually going in a different direction to the road, but they give you the impression that they're following the road. These can all give you the wrong impression about the road and help set up expectations which are not met and increase the likelihood of mistakes. So, you know, getting a smooth and flowing alignment where you can see through these profiles becomes really important when you're looking at curves. The other one that I want to talk about now is the out of context curves. This is some work that was done by WSP's Peter Senek a few years ago, which looks at the difference between the approach speed to a curve and the crash rate on the curve. And if you think about it, what he's saying is that when the approach speed is within 10 kilometers an hour of the curve speed, you've got very few crashes. The minute that you go up to a difference of 30 kilometers an hour between the approach speed, and it doesn't need to be a straight, that could be the departure speed of the previous curve going into it, this crash rate doubles. And so understanding what the degree of in context or out of context is vitally important, because that ties back to those FHWA statements. You know, it's out of context, it's violating expectations, we get more crashes on them. And you know, when this rises quite rapidly. And if you think about your signing system that you have for curves, you know, we don't do anything typically with 10 kilometer an hour difference. We identify a bend sign sort of in here. Once we start getting up here, we're starting to put the chevron boards, and then we're getting up onto the 30Ks. We've got the speed advisories and things. The speed advisories are a really interesting thing that Sam Charlton did at Waikato University, did a lot of work on speed advisories on those boards. What he tended to find was the number that you put on the board had very little to do with the negotiation speed. The fact that you put in the 4 chevron board and the single chevrons around the corner and the quantity of signage is what gave drivers the clue. It gave them the clue, you know, hell, there's a lot of signage on this curve, I better take it bloody carefully and things. So it wasn't so much whether he had a 65 or a 45 or an 85, he got very similar numbers. And that relates to how you warn drivers that things are out of context. One of the biggest problems that we get with out of context curves comes downstream of the project. And this is a real problem. What typically happens is that a project continues to be built up to the point where it gets too bloody expensive to go any further. And unfortunately, that usually means a bluff or a hill or an embankment or a bridge or something that's going to cost bucket loads, and it stops. And so what you're tending to do is you're doing a nice alignment and you're improving things, and then suddenly the thing at the end, which you used to come into at 10 kilometers an hour difference off a windy alignment into another windy curve, we've straightened the first bit out and we're coming in at 30 kilometers an hour difference, and suddenly we've got crash migration onto that curve because it is now out of context when it was previously in context, and it causes problems. Now, one of the most frustrating things that I find when I'm doing audits and we look downstream of the project is the project manager who says, this is out of scope, you've gone too far. You can raise the single finger salute to them because it is in scope. You're creating a crash problem on the next part of the network, and we have to be really careful. It's interesting, I've just done some Austroads work on passing lanes. And what we found was, of the passing lanes that were installed in New Zealand, almost half of those that were installed resulted in increased crash rates either downstream in the 5 kilometers downstream of the passing lane. So this whole idea that, you know, it's going to reduce driver frustration and make things safer was a complete crock of shit. We got increased crashes. Why? Because we were bringing traffic at a higher speed off the end of passing lanes into areas of substandard geometry, because if it was good geometry, we would have kept extending the passing lane. And so it's a real issue, and up to 5 kilometers. So, you know, when you're looking at this issue of crash migration, my rule of thumb is let's drive down the road for 5 kilometers in each direction, upstream and downstream, have a look and see what's going on. And it's not out of scope, because that's where we know we're driving crashes. So in terms of the curves, those are the sort of the three things that I sort of want to talk about. In summary, it's curves that are hard to read, curves that are out of context, and this whole issue of crash migration. And if you take away 3 takeaways from today, I'd be happy with those 3, if that's okay.
Yeah, that's excellent, and you're getting a lot of support from the group there on a lot of your comments there.
Okay. Oh, that's good. I can't see it. So.
Yeah, no, that's all right. I'll feed any particular questions to you. Just a lot of people agreeing with different aspects of things you're saying, and that the discussion on where is the scope of works for a road safety audit is a really good one. I talk a little bit in the final module about it, and sort of that idea that the works will influence the area is so important. I mean, driving out for 50 kilometers to your audit site, you'll see many things on the way that you will be no doubt disturbed by as a road safety auditor, and certainly you can mention those to the road authority, but they're not part of the audit as such, unless, as you say, the new works have influenced that.
Yep. And I think this, you know, the fact that we're improving design speeds and operating speeds becomes really important. The next one I want to talk more is I want to move more into the urban, if that's all right. And this is probably stepping back a little bit. Design audits, particularly in I think more in urban areas. We need to have a look at what's going on, particularly in the pedestrian and cycle space, the traffic data and who's using it, and I'll talk a little bit about that. And when audit first came out, there was a whole lot of sort of talk about, you know, we shouldn't necessarily have the crash history because we're talking about something new, but actually having the crash history gives you some idea about what the scheme hopefully will contribute to, and if it's not, where it could make it worse, but it shouldn't really drive the audit. It's not a crash reduction study. You're actually just looking at what's going on site to better understand what's going on. But one of the big areas that comes up is heavy vehicles. Now, surprisingly, their crash exposure is not as great as it might be, but it is something that seems to come up time and time again in terms of the potential for crashes in urban areas, and getting the right heavy vehicle. And if you can get it right for the heavy vehicles, then it's probably right for everybody else. But in Austros, there are 2 things. There's a design vehicle and a check vehicle. And who can tell me the difference between these 2?
Okay, so pop your ideas into the chat there. We've had one's popped in already, but we'll see if we get others that want to pop something in slightly different. We've got Nick's popped in that the check vehicle can make it. The design is within the lanes. The design vehicle is within the lanes. We'll see if anyone else wants to put something else forward, or no, it looks like everybody's gonna stick with Nick's idea there.
Yep.
What are your thoughts on that? There's some good elements to that.
Yeah, no, he's got it pretty well bang on. I mean, what we're talking about is the design vehicle, and particularly, I mean, in New Zealand, there's a requirement for them to manoeuvre completely within the lanes and things for the design vehicle. So, and then the check vehicle should actually fit within within the formation. And within the existing hardware, as opposed to an OD where maybe you have to remove signs and lift them out and things like that. But often they get confused, and particularly in urban areas and things, you know, it's not a matter of designing every bloody roundabout and every intersection for a 20-meter B train. You know, what you should be designing is what's the common vehicle that's going through. And for New Zealand state highways, that would typically be a quad axle semi. And then looking at what you might also get. But on some low volume roads, you may not get milk tankers. You may just get large single units. And as long as you've got a check vehicle that's a milk tanker, then you're all right. But it's important to understand that difference and to understand what it is that's been assumed and why it's been assumed as you go through. The typical things that come unstuck, if you like, with is this wrong vehicle, wrong choice of design vehicle. And in urban areas, it's actually quite interesting. A lot of people look and say, well, we won't get a quad axle semi down this residential thing, but you could get a school coach. And one of the problems that you get with a fixed bodied school coach without steering rear wheels is they generally have a much wider swept path because they've got no articulation points and they've got leading front overhangs and things like that. So you've got to understand what vehicles are likely to be using and how they're going to use it. And then the two things is, one, the swept path cannot be accommodated. And there's the fact that it can't be accommodated, but there's also the fact that it's not natural. And I'll show you an example that Ken has about a swept path that can be accommodated, but my experience of driving coaches and things like that is that there was no way in hell that I would drive that swept path. I would make a single curve out of it and things. The other is all swept paths that we put in design have a speed of design built into them. And one of the things that you never get told when people send you the swept paths of vehicles at intersections, which I always ask for, is what was the speed assumption on which the swept path is based on? And then you have to say, does that ring true? And I'll show you some in a minute that don't. Swept paths that don't account for the driver view angles. I did some work years ago at Kennedy Road in Napier, where every time a truck crossed the intersection, it would swing into the opposing lane. And I went out on the site and I watched for a couple of hours, and every bloody big truck ended up crossing into the opposing lane. That's what I went back and I said, there's a problem. The designer showed me that the swept path could be completely accounted for in the lane at that operating speed. What he didn't account for is that it was on a curve and the drivers could not actually see out their cab windows at what was coming unless they came in on an angle. It came in square, and if they came in square so they could view out through their cab windows, they couldn't actually make the curve. He had assumed that they'd come in sort of on quite a flat angle, which meant they couldn't see the approaching traffic. So again, sitting there, and I'll show you an example as we go through, sitting there and working out where drivers are looking and what's blocking their viewpoints. And then the other thing that often happens is that you'll find the takeoff point at the start of a roundabout or an intersection, you have to be really heavily over to the right, then move to the left so you don't get into trouble exiting the roundabout. So you have to be correctly positioned at the start to stop getting into trouble at the end, which is what you can't see. And so you have this issue. So these are some of the key things that come up. And they end up coming up with encroachment of the other lanes, encroachment of the pedestrian space, and conflict with the other intersections, and then with roadside furniture. So I'll just go through a whole bunch of examples now.
Yeah. Mike had popped in there a bit about furniture and traffic signals and hire vehicles and the like, which I think is a really good point. And I think you've got some photos of some furniture later that sort of gets a bit damaged from those swept past. I think it's an interesting one, isn't it? Because you've got if you're not accommodating the large vehicle, you get some of those issues. But often if the design vehicle is chosen well too big, we see these very wide sweeping areas where high speeds around curves over pedestrians. So it's a bit of, you've got to think of both sides of it, don't you?
Yep, you've got to make really sure that your design vehicle is a sensible vehicle, and too many times I've seen what is really the design based on the checked vehicle, and that's not how it should be. So I'm just going to show you this one. This is one from Auckland, which is an interesting one, because if we're having a look through here, this vehicle that's traveling up the page here cannot actually negotiate that curve and without going into the other lane.
I'm not quite seeing your cursor there.
Are you not? Am I on the wrong?
Yeah, that's it. That's it. Thank
Sorry,
you.
I was looking on the wrong sheet. So this vehicle coming around here has to travel into this lane in order to make that curve and things. And in order to do that, they have to be well set up near the lane line as they come in here. They have to come in tight here. They have to flatten a little bit through here to get there. That's just basically an ugly curve. The other one in this case here is the potential for two vehicles, and one of them's a truck and trailer unit. The other is a single unit. But this is a big industrial area. So it's quite possible that you could have that combination, and then they encroach on each other as they come through here. They don't actually have the separation that they need to make that maneuver. Interestingly, it's not obvious on site that they haven't got that separation. If it was obvious on site, I think the behavior that you would get would be, you go first, no, I'll go first. But the fact that it looks like you can get round until you get into this area here is again leading people to one behavior which it's then violating. So that's a sort of this one here, it's on signals. This is a signalized arm here, so it's possibly not so bad, but this is a giveaway as we come through here. So in theory, the vehicle could still go around, but they're going to end up in the opposite lane. I mean, the big thing with these is making sure you've got the clearances between the vehicles, which is what we're talking about in here, and that's what's missing in here in particular as we go through. This is another one. This is one of Ken's. This is an interesting. This is the one from the bus station, isn't it, Ken? Is that right?
No, this one isn't. Yeah, the next one I think is the bus station one. This one was an interesting one. It was part of a planning permit application that came in. So the developer, developing the land, and the traffic consultant engaged and designed, and this was put to the road controlling authority as as showing that the intersection that they've got planned works.
Yeah, and I think the big issue here is, I don't know who drives. I until recently I drove trucks and buses, so there's no way in hell I'm going to do turn, slight reverse, go forward and turn. I'm going to do that in one movement. And if I do that in one movement, then I conflict with the opposing turning vehicle. And it's a sort of classic that the only way you can get round there is by doing this Mickey Mouse turn, and it's not natural, and it's not going to happen, and it's going to cause problems. So yeah, this is this area in here. And again, looking at this one here, it's impacting on the road furniture as you go around. And yeah, so there's a lot going wrong in this in terms of the heavy vehicles traveling around and unnatural behavior and encroachment.
Yeah.
This one here, sorry.
Oh, sorry. If you go back to that one, sorry, Virgo, I just wanted to a couple of things on it. One thing that I always sort of look for in these designs is when I see those little arrowheads in the swept path, I know that there's a turn that's been added in there, and you know, seeing those at the start and the end of the swept path is fine, because that's exactly as you say, expected. But then when you're seeing them in there to adjust around and move around things, it's a bit dodgy. And the other one there was that standards review finding. That was more just in that differentiation between what is a road safety audit issue, which the interacting swept paths, the sweeping over the furniture, and potentially, you know, challenges with the property boundary. But that one's like an electrical service that will cross a property boundary, which is generally a no-no. But you know, that's not a road safety issue, is it? It's okay. That's you know, there's some legal implications and those sort of things. But are people going to be killed or seriously injured because that crosses a property boundary?
Nope.
No. So
but you might mention it to your client. That it's not, and I mean, over here on this side here, and this one here, we're really, really close, and you know, another issue. It's probably not a road safety issue, but it may be worth a mention to your client. The other one that I want to talk about next is this one. This is a really interesting one. This design speed, if we have a look, I don't know if you can see it, the vehicle simulation on this has been done at 5 kilometers per hour.
Right.
Now, it's a long rigid bus. It's struggling to get round here because of these curved lines through here. You can see how close it is. If it tries to make that turn at 20 kilometers per hour, there is no way in hell it will get round that curve. It's just not going to happen. This one here in this direction, this is the bus station one again, because it's got buses on it. It's going over the footpath through here as you go through. And there was some work done by Frank Lai at Leeds University, the late Frank Lai. He was looking at pedestrian bus conflicts. Do you know what the main pedestrian bus conflict is? Pedestrians standing at intersections, getting their heads bashed by the wing mirrors of buses. Which, if you think about it, it's you know, and this sort of situation, if you're waiting to cross in this area here, well, this isn't actually just going to bang you, it's actually going to come on right onto the footpath. But you've got to understand where that part of that vehicle's going in terms of the pedestrians and what's happening through there. But 5 kilometers an hour, he won't. And again, this is an interesting one. Got to cut the corner here to make sure you're back inside over here. And at 5 kilometers per hour might be all right for low speed bus. But when I come down to, this is also in the bus depot. And again, we've got conflicting paths with this one coming around here, which can go at the same time as the left turn, probably.
Yep.
Even though it's signalized, they're overlapping. Why are you designing something that's going to be used, in this case, hourly? And you know, and you can write the story. These swept paths overtake. This is a regularly used thing. It will lead to an increase in the likelihood of side swipe crashes. So you know, that's what you're talking about. You can write the what it is and why it's important, because it will lead to an increase in side swipe crashes. This one here, this is cutting over the footpath. This will increase the likelihood of pedestrian conflicts and crashes. The low design speed means that at higher speed, this is likely to result in this tracking curve not being appropriate and encroaching on the footpath in the pedestrian area and increasing the likelihood of crashes. So we're going through there. This is an interesting roundabout, Namatahu in Masterton. It's a bit hard to see, But of particular interest is this maneuver, this is the heavy vehicle bypass. It's got a couple of things going on. It's got quite a tricky set of curves through here where you run into strife here if you don't set yourself up well back here. And similarly, if you don't set yourself up well back here, you run into strife over here. And this idea that you run into strife exiting something because you got it wrong on the entry is quite difficult for trucks. The other thing that happens in here is, as you come through here, you've got to change lock. And again, if you're designing it at a very low speed, you're imagining that somebody's turning quite heavily. The minute that negotiation speed goes up, the drift increases and you don't follow that swept path. And that means that you encroach on other lanes and increases the likelihood of sideswipe crashes. This one here is the one I talked before about not having lined up for drivers' viewing angles. This is a heavy vehicle turnaround because we've got a median barrier here in red. And the idea is you're going to come in here and you're going to sit here, and in order to actually get out without hitting the median barrier, you've got to be on an angle, which means that that driver's cab window is blocking what's coming around this curve. He's actually got to hang out to have a look to see what's going on. So while the swept path all makes sense, making sure that the drivers can actually, that they will follow that swept path because it's the natural swept path for them to follow, and that they're not buggering up their sight lines becomes quite important. So yes, all the swept paths work and he gets around inside the median barrier at a reasonable speed and everything else, but it's more likely that this vehicle will come in squarer so that they can see, and then they will struggle to get round. Does that make any sense?
Yeah.
So, yeah.
Yeah.
So understanding where people and you know, as I said in that Kennedy Road example, we just needed to sit on site and watch where the drivers were looking and how they were looking. It became very, very obvious, but it's really hard to tell when you're looking at something on plan and it all looks like it's going to work. And when it doesn't work, of course, and when you're out on site, you know, this type of thing is quite common. This is a particularly good one. That's 1.5 meters worth of track in there to get round here quite clearly and things. So there's quite a lot going on. Who was talking about road furniture? You're right, you know, and things. And even with OD loads, I mean, this is one where somebody's just hit it. And I mean, with your ODs, you've usually got pilots who are actually lifting the furniture out of the way and things. But the number of times that they put the furniture back wrong after they've lifted it out of the way is really quite horrendous. We had one in Northland where they put the indicator marker for which side of the traffic island to go on around the wrong way. And ended up with people going down the wrong side, which caused problems. So, you know, heavy vehicle negotiation, although it's quite tricky, but it's worth looking carefully at, I think. The other thing that's, sorry, yep.
I was going to say, so before you jump on to sight line, sight distance and the like, just a couple of things that have come in. I'll just mention here. So Mark Love's made a comment around that one where sort of 5 kilometers per hour was the speed choice. The question is, has the modelling of the intersection been carried out for vehicles travelling at 5 kilometres per hour? Impacts phase time required to clear and capacity of the intersection and overall intersection efficiency and the like. So showing that interaction there, I suppose.
Yep. And the other thing is that, yes, I mean, you could argue that a vehicle pulling away from stop at that signalised intersection is probably doing 5 kilometres an hour as it begins to pull away. But the one that's coming through at the end of the phase or on the orange, that's doing 30 kilometres an hour.
That's right.
and
Yeah.
it's not going to get round. So I mean, you're quite right. So and he's quite right. I mean, if you're designing everything for it, you end up with a lot of dead time and a lot of things going on. So I think what's happened there is the heavy vehicles have almost been an afterthought to make sure the intersection works for them, and it's been made to work, and it doesn't naturally work, I think is probably what I'm trying to say.
Yeah. Now, Ferg, we usually have a little stretch break and a fill the water up break about now. So we're still running beautifully on time. We've got plenty of time to go to get through the rest of the topic. So I'm going to just pause things, and we'll come back to it in 4 minutes time. So
okay, that's good. Yeah, I've only got about 10 slides to go, so that'll work well. Okay.
Yeah, perfect. All right, 4 minutes, take a stretch, and we'll be back into it. We'll get back into it shortly, Ferg, but while people get settled, they're going to do a little desktop review of a design as their exercise after this session. I'm not providing the swept paths for this because I want to keep it at a certain level. But if you were to be undertaking a road safety audit and not given the swept paths, what would you do? Or they say we don't have them, or they're not available.
I've certainly in the last little while done a number of audits where they haven't been provided. And in each case, I've said, no, you need to provide them, and you need to tell me what design speed that they've been done at, and things. And I think they've always come through. Sometimes it's weighted, but it's. I mean, some things like that. takeoff angle, the one with the turnaround, that's going to be reasonably obvious, and you can make comments. But I mean, I think in most intersections, it's important, and we just ask for it.
Yep.
And if they, I mean, the crazy thing is if they're not available and they haven't been done, you've got a real issue on your hands potentially. So, you know,
Yeah.
you can't go to the client project manager and say, "Oh no, we're not providing them because we haven't done them." I mean, that's part of the design process.
Yeah, that's right. There'd be a whole lot of red flags if they said, yeah, no, can't do that. And we see there Nick and Mike are both along that line. You'd be pushing back and saying, come on, please provide them. Or maybe in the absolute worst case scenario, some very clear, specific statements in your order to say it was excluded, and that's out of, but that's not a good outcome.
I don't think I would say it was excluded. I think it would say that it had not been provided, and that we have a safety concern. I think the idea that it's just been excluded makes it a bit like the lighting or the landscape drawings. I think it needs to be a bit more forceful than that, particularly if it's a constrained site.
Okay, there was one more question. Haran's just asked, and is there any relationship between crash risk and the road roughness?
The answer is yes. There's work that's been done by Peter Senek in particular, looking at a number of variables in terms of roughness, skid resistance, warp, horizontal alignment, and things. I seem to remember that it was complicated because at high levels of roughness, speed is reduced significantly, and you actually get a safety improvement at high levels of roughness because the speed has come down, whereas at I was going to say medium or intermediate levels of roughness, there is an impact with suspension excitation, which then reduces the contact area of the tire. So it's not a simple relationship. I seem to think it's possibly U-shaped because of this suspension, and it depends on the wavelength of the roughness as to whether you get the suspension excitation. It's a few years since I've read that work, but yeah, at really high levels of roughness, safety improved because we believe because speed went down and things because it was so unstable. So yeah.
Yeah, no,
but there's some good work by Peter Senek. It's a NZTA research project. And there was another one more recently by Lonrix, which was looking at maintenance issues and road safety. And again, the big player that came out of it was skidding resistance, but roughness also featured.
Yeah, no, good question there. And I suppose like any of these questions and those who know Ferg, there could be many hours of discussion on each of these, which we don't have time for, but Ferg's contact details are in the slides, so you could follow up with him on that, and of course you can contact him through me if you lose that for some reason. But we'll let you keep going with a few of the other points there. So sightlines.
Sightlines, yeah, I mean, aside from active road users, which I understand Ken talks about in one of his other sessions, and the heavy vehicles, which we've just talked about, the other big one in areas is sightlines. And there are a number of sightlines that we need to pay special attention to. I mean, I think from memory, there's about 7 or 8 different types of sightlines, but the things that we need to be thinking about are the sightlines to a feature. And in particular, I'm thinking about intersections. So actually knowing where the intersection is and where to stop and where to position the vehicles and things like that, those sight lines require zero object height looking on the pavement. So much of our sight lines that we have are typically based on things like safe stopping sight distance, which are supposedly to a 200mm object height. I've always wondered where that 200mm object height came from, and I was told once that it was actually if there was a body lying on the road. But I'm just standing up, and I don't think there's 200mm in there. I'm sorry.
I'd heard the body one as well. I'd also heard a cinder block or the like on the
Yep.
road. So we'll
So anyway, that's I'm definitely more than 200mm when I'm lying down. So anyway, but I think so understanding what the sight lines, and so I mean when we look at crash investigations, particularly around intersections, the first one you're looking at is you're asking yourself, was the intersection visible? Did they know that it was there? Was it appropriate? So you've got sight lines to the feature. Having got there, was the sight line, did they see the approaching vehicle? Was that sight line obscured? Or if they did they misjudge the distance and the speed of the approaching vehicle? So was their perception of that sight distance distorted by other features that are going on around the place? So we need to have a really good look at sight lines, and particularly things that will obscure them, such as the alignment, as I've said, and parked vehicles and road furniture. And again, we've talked about, I think, the stand-up angles at intersections, where that vehicle has to position itself in order to see, is that the natural position for it? I mean, the common ones that we typically have for side roads are the safe intersection sight distances, which are measured, from point back to help you make that decision and see where you're going. I mean, that's probably the most common one, and things. But often when we're looking at and here's this is an Australian picture that I stole from Ken on Ida Street, but the issues that we've got here, they're planning to do something with this shoulder, and what's it going to do to the sight lines on this intersection here as we go through? And what they actually end up doing is allowing parking right up to here. So what could you do in terms of this sight line? And if you have a look, I don't know if you can see it, but that Mercedes is just there, and then it's just there. Sorry, I'll do it on the other one. It's just there, and then it's there. But what would you do at that site if you were faced with that problem? What, I mean, the recommendation is that the sight lines are obstructed by parked vehicles, which obstruct the view to approaching vehicles and are likely to increase or will increase the likelihood of T-bone crashes. What could you do?
Yeah, let's see what people pop into the chat. There's been one or two ideas come in. Let's see if we can see a few others. Okay, good, a few coming in. So we've got move the limit line out or NSAAT markings to increase sight lines. I'm trying to work out what that acronym is. NSAAT.
No stopping.
I'll ponder that. Jem has said build outs. So curb outstand build outs, ban parking on the approach, take out parking, extend NSAAT. Lots of people on that acronym. No stopping at all times. Okay, sorry. Yep. Delete the first two parks. Lots of, yes, thank you everybody for clarifying the acronym for me. That's good. Remove parking, move line out, leave a gap between parking. Yep. Ban parking. Lots of people wanting to get rid of parking. challenging thing. We're working for a local government controlling being responsible for parking, and removing can be a very hard thing to do occasionally. But
It can be. I mean, you could signalise it.
yeah, that's right.
Or
Yeah.
you could say to them, we'll signalise it or take out the parking. What do you want?
Yeah. Yeah, good. So some really good ideas there. Any capture your attention particularly there, Ferg, that you really liked, or
I think
give away?
I think the curb build. I quite like the curb build outs and moving a limit line further out. I think is possibly quite useful here, because it will also help pedestrians in that area, and things. We know that the curb build outs for pedestrians is a significant safety improvement. So you're doing a couple of things at once. Maybe taking out you could take out the first park, but to be honest, it's not going to make that big a difference. You might have to take out two or three, and that's starting to get quite a long length and push back. I like the idea of building out. Typically, that's my, well, it depends. It's not the answer to everything, but it's well worth having a look at.
All right. Well, I'll give some prizes away there to the Nick and Gemma, who are the first two to get those two into the chat. They were quick out of the blocks.
Okay, right. So I think, yeah, we've got the Mercedes. That's right. I mean, the number of sight distances and which damn sight distance. There's tables and bloody tables in Austroads. The big thing is to think about what drivers need to know. And the other thing that I think, particularly with intersections, is that you're often talking about the entering sight distance as the sort of the sight distance that you have for a driver to enter a gap without disturbing the through traffic. It's bloody near impossible to get. And so unfortunately, what we end up doing is defaulting to safe stopping sight distance, which is, you need to be really careful about that, because effectively you're changing the priority of the intersection. You're now relying on the through road vehicle being able to stop in time if somebody pulls out of the side road. And that's not an expected behavior. So again, you want bigger allowances, you're violating somebody's expectations. So although I think Austroad says, in many cases you cannot supply entering sight distance and you should have a minimum of the safe stopping sight distance, you've got to understand that you're effectively changing priority. And there's an intersection near my home, and I said to my mate the other day, I said, if you ever have a crash on this intersection, call me, because it's got so many things wrong with it that I'll get you off. And the main thing is it doesn't have safe stopping sight distance, and it needs it because the sight lines are so obstructed you can't get entering sight distance. So the other one that I think is quite badly understood as maneuvering sight distance, particularly when you're looking at the difference between approach sight distance and maneuvering sight distance when you're looking at things like lane gains and mergers and divergers and things like that, because those are the sight distances that you need to be able to see those features and make the right decision. And it's often interesting, people will say, a low workload environment like a motorway, there's not much going on, so you can use a smaller perception time. That's nonsense. There's not much going on and people are desensitized, and you actually should probably be using a longer perception time, because this thing is an unexpected thing and it's going to take them longer to register and adjust for it. So, because your sight distances are typically sort of 2.5 seconds, 2 seconds. You better And the other thing that I think that you need to have to think about is often when we're looking at safe stopping sight distance, you've got two components to that. You've got the perception reaction time, and you've got the braking component. The number of times I've seen people use the minimum perception reaction time and the maximum braking time, and I personally have an aversion to minimums on minimums, and that's effectively where you're going by doing that. I typically say when I was at the agency, if you want a departure for that, you do one or the other, but you're not doing both, because again, minimums on minimums are just giving you trouble all the time, and that will increase the likelihood of crashes, particularly rear ends and T-bones.
Yeah. Yeah, Mike's popped in there, the 2.5 second reaction time there for the generally considered those longer outer monotonous routes where people are drifting off into other things they're thinking about, and usually down to the 2 second, I think, reaction time in the other areas. But he's got a point, maybe one just for us to everybody to have a think about. But when people drop back SSD, arguing for lower speed limit to reduce that further. So altering the speed limit to reduce that, but not applying any sort of speed reduction calming measures. So, in theory, everything's working, but, maybe we're not quite getting that. So I think it's a good point.
It is a very good point. And I think, I don't know, there is a requirement, or the requirement under the old setting of speed limits rule, that you needed to have your operating speeds within 10%, has now been dropped in the May 19 version. While I thought it was fairly arduous on the local authorities, I think it had a point. It was saying, don't set, as exactly as you're saying, unrealistic speed limits to make the design work.
Yeah.
And I think that's a very good point. So common issues. I'm hoping these guys get these. You get copies of all the slides, don't you?
They've got the slides. They've actually there's quite a few people have done little research assignments on some of these. Certainly, stand-up angles has been done. Landscaping, road safety and landscape. Danish offset, the Z crossing being done. Good, one on that. So there's a few of these have already been knocked off, and they'll have the ability to look at somebody's assignment on it. But any particular ones there that really, for you, Ferg, you sort of say, well, that's a really juicy one?
Back of queue issues.
Back of queue.
Back of queue issues. The number of times we look at safe stopping sight distance to the intersection, and we know that at certain times of the day, there's 30 meters of queue. And what you really want is safe stopping sight distance to the end of the queue, and you want, and again on motorways, where you're looking at the situation where the ramp, you do not want the ramp vehicle decelerating on the through lanes, because it's going to join the back of a queue, and so it's starting to slow in the through lanes because the queue is extended back up the ramp so much. That's a key one. We've talked heavily about swept path turn issues, so that's one. And one that doesn't get considered as well as it should be is paint on the road for motorcyclists, or I'd actually go further and say any shit on the road for motorcyclists. A lot of people, they don't think about the motorcycle stability thing. We had a binge on tourist arrows for drivers overseas tourists who pulled out of rest areas and went down the wrong way. And we were putting in tourist arrows everywhere and trying to get the guys to not put them in on straights, not to put them in on curves, only on straights, and only with sight distance onto the arrow, so that motorcyclists can see it as they approach and they're not canted over when they come to the paint. But we have the same problem with urban intersections. it was only the other day in the rain, I was walking up and I watched a scooter braking at light and hit the straight through arrow, and did lots of wobbling, and generally it was pretty all right. They think they cracked their fairing and something as they fell over, but you know, it was the classic. And you know, so making sure that we're not got paint or debris. And there was some work done by Tim Dredden a while ago, looking at how far back up we seal rural driveways based on their slope and their shape, to stop detritus from washing out onto the road and impacting motorcyclists. And you know, it's a simple thing that you can do in your maintenance specification. I think it came out, if it was a certain grade, it was 11 meters, and that makes things so much better. So understanding all of that. Another one is that not enough space for pedestrians. The number of times I've seen two-stage crossings where the splitter island that separates the crossing is 1.2 meters wide. That's not wide enough to have a pushchair and a person. It's as simple as that. If you're going to do it, one of them's going to have their bum in the traffic. It's either the baby in the pushchair or the pusher, and making sure that you've actually got the space for the intended users. The Danish box offset, I've actually just recently looked at one where I said, oh, you've got it round the wrong way. And it was quite interesting. They came back and said, if we do it the other way, we end up off the desire line. And we actually, we think that we're better off doing it this way. It's signalized. We're better off doing it this way because it's signalized and it fits the desire line better, rather than taking people in the opposite direction. And I thought that was good thinking. So it's not just a simple black and white thing. And yeah, transferring issues to it. This whole idea of crash migration and things.
So they're intersections. I think your next one's
which is mid-blocks, which is very much the crash migration one. Yep.
Well, while you do that, sorry, Colin's asked about what dynamic visual obstruction is, and if in our module 1, where we looked at the new intersection and the left turn lane, that one sort of is a particular issue of dynamic visual obstruction. So Colin can have a look back at that. It's basically where one vehicle blocks the sight lines to another. So back to you then, Ferg.
Yep, and there's some very good work. There was some work done by Dr. Shane Turner on left turn slip lanes and seagull intersections recently, an Ostrode's research report where he looks at that, and also Cherie Mason's master's thesis on dynamic visual obstruction. Both of those look at that and how you manage it and look at the crash issues associated with it. So they're worth having a look at. You can go to the Waka Kotahi research site and download a spreadsheet of all their research reports, and then click on the links in there and it'll take you to it. So you're looking for Shane Turner's work on seagulls and left turn slip lanes. Roadside hazard management, probably all of the work from IRAP to OSRAP, KiwiRAP, IRR, all of the risk assessment programs, roadside hazard management is the biggest single component on crash severity. And managing your roadside hazards, it's as simple as that. I mean, there are still some people who are wedded to clear zones. I don't like those people. I struggle with them. I had a job recently where the auditor said that there was a clear zone of 9 meters, so therefore all these concrete head walls that were at 905 were fine. And you know, people hit them. Clear zones were only 15% in theory effective. What we find these days is that as people come off the road and you've got a big clear zone, if they don't strike anything, then their rollover increases dramatically, and as the yaw goes up. And so even where they didn't hit hazards, the rollover results in death and serious injury. And unfortunately, typically young people, alcohol, no seat belts, multi people in the vehicle seems to be a pattern. A personal hate of mine at the moment is line marking issues. Particularly ghost markings on long-term construction. I think, and I know this is deviating a little bit, Ken, but I think that we need to be far stricter on our auditing of construction sites and construction management. And if something is going to have more than 3 months duration, I believe that the temporary roadwork should actually be fully designed and properly managed, and this idea of ghost markings and things just is just not tenable for high volume, long duration work. It should be as good as it gets. Skid resistance. I mean, skid resistance is one of the key things. It tends to be more associated with maintenance. And what you tend to find is the places that you need the skid resistance the most are the ones where it wears out fastest, because skid resistance reduces as vehicles scuff across the surface and effectively polish up the stone. And so tortuous alignments where you want that high skid resistance is the place where you're going to be losing it. And your out of context curves where people come in too fast and you need to give extra skid resistance, you're going to have problems. So setting the right skid resistance in your maintenance strategy becomes really important. It's probably not really in the audit, but curves, I mean, for me, it's typically been curves, curves, and curves, which is why I started with curves. I think the rest are reasonably, blind mergers, not providing site distance to mergers and divergers or minimum site distance. When you drive it, particularly, I'm just looking at one that I drove through this morning. I don't know what's wrong with it, but as you drive through it, you know it's not right. You know, now I've got to sit down and find out what's wrong with it. But there is something wrong with it, because shit, it feels bad. That's easy to do post-construction. It's almost impossible to fix post-construction. But trying to understand what's going on in terms of getting that site distance and that reaction time and things like that. The other one I think that we haven't talked so much about here, we've talked about mid-block. I think road type is really important. Two-way rural roads are very different to motorways and freeways. And I think you need to have additional or different skills to do motorways and freeways to what you would do on a two-lane rural road, and particularly around reaction times and line markings and mergers and divergers and all of those things. I think it's a specialist business area, and I mean, it's not harder or easier than two-lane rural roads. It just is different, and we need to be very careful about how we go about it. Yeah. The last thing I want to talk about is prompt lists or checklists. These, I'm going
to talk a little bit about it also, Ferg, so you don't need to spend too long on it.
Okay, I was really going to say, when I first started auditing, I used the prompt lists that we had extensively, particularly before I left site, because there's nothing worse than getting back to the office and then thinking, oh, fuck, I didn't get that. And then you're faced with, do I go back out to the site? Am I looking through my photos, trying to find something? Whatever. If you go through, particularly when you're starting out, I think it's really good to have those in the back of your mind and quickly go through them before leaving site to make sure you've covered off, and also before you hand your audit report in, so that you know which things you haven't done, and you need to be able to say, I haven't done the lighting, and I haven't done the this, and I haven't done the that, and they will need to be done at a later stage if they're important on this job. The way the prompt lists are set up is they're effectively a hierarchy. So you've got the detailed questions, and then you've got the main topic areas here. Over time, and these are different from the New Zealand ones that we had in the old ones, which was very hierarchical. I would use only, when I first started out, I would go through these in detail. Later on, I would just go through these 20 headings as I got more experience. But I think using the prompt lists is really important to make sure you cover off. And interestingly, where I've come unstuck the most when not using prompt lists is where I've done a big audit report and the thing has got a whole lot wrong with it. And I've written and I've written and I've written 40 something pages of issues and things. And I think I've done everything. And then I realized that I've left something out because I got so focused on the bit that I was getting worked up about that I haven't done it completely. So I strongly recommend, particularly people who are starting out, to make good use of the prompt list. It's like using the index of any book. It you shouldn't be ashamed of it. I think it's a good mechanism to make sure you get everything done when you're on site. And then as time goes on, you'll just find you just need adjacent land use, pedestrian issues, public transport, those headlines, and that'll get you to make sure that you've covered everything off. I think the other thing that becomes important when you're on site is photographs. I seldom write any notes when I'm doing a post-construction audit. I just photograph the crap out of everything, and then I go back to the office and I use the photographs and they tell me what it was that I was looking at. Because if I photographed it, there'll be an issue and I need to work out what it is. When I'm doing design, now that we can snip from design drawings and PDFs, in the old days, you used to have to write half a page just to describe the scene that you were talking about, and then 2 lines of this would increase this crash problem. Now you can stick in a picture like we have with the turning circles, put a bloody circle around the bit that you're worried about, and then write a couple of lines. It makes it clearer for the audience, who are often not as technical as you, and it makes it quicker to write going forward. So I strongly recommend photos, prompt lists, and snip tools in the audit. And that's pretty much me, unless somebody's got questions.
Oh, you've done beautifully well there, Ferg. Thank you. Some comments in there, but I think I cover a little bit about some of the front-loading questions that are now being included in Austroads, and yeah, some agreement with the photos. Mike out there yesterday taking lots and lots and lots of photos. We have it. I couldn't agree more on the photos. I'll often dash cam the whole area as well to capture it, have that, and then out traipsing around with the team taking photos. So yeah, you don't want to have to go back out there because you just can't quite remember exactly how something was. Well, thank you, Ferg. That was wonderful. Really appreciate that. I'm just going to cover off a few more things on prompt list, not too much more, and then introduce the exercise for everybody to do. You're welcome to hang around, or if you've got audits to write up, you're welcome to.
No, I've got a meeting for the new Wellington Transport Alliance, so I will head off to that. And thank you very, very much for the opportunity. I'm sorry it took me much longer than we said it was going to take. I'm sorry, Ken, but I've thoroughly enjoyed it.
Well, I did the old trick, Ferg, of telling you less time than you actually had available, and we've pretty much hit the nail on the head perfectly. So okay, that's worked well. Thank you. And as I said, Ferg's contact details are on one of the first slides there. So anybody who wants to follow up and delve into a few more of these things, they're welcome to contact him, or they can chat through me. Thanks, Ferg. Okay, see you, Ken. Take care. And thanks everybody for joining, and say hi to all of the guys who said hi. Thanks. Okay, bye. Great. Okay, so I'm going to just share my screen now, and oh, there we go. may have, yes. Good. Hopefully you can all see that. It's saying you can, so I assume you can. Not much more to cover. Ferg did a good bit there. There is one part of the, say that Austroads used to call them checklists as well, but there was a distinct choice to change it from checklist to prompt list, because the concept of a checklist indicates that if you just go through each of those, you have covered everything. And we really wanted to move away from that. They were just to prompt thinking, to spark ideas, to get people thinking of these different topics. There may be things that aren't covered in the checklist because of the context of your specific audit or the like. So you've got to really think widely. There was also the inclusion of this front-loading area, which asks general questions about the project to help you sort of gain context of the project. So that's in there at the back of part 6 as well. And we also then see we've got the different prompt lists covering local alignment, general aspects, intersections, walking and cycling, traffic signs, line marking, lighting. And then each of the columns are feasibility, preliminary, detailed, pre-opening, and existing roads and pre-opening. So you can sort of go through each of these. They're at the back of the Austroads guide. They're quite detailed. And as Ferg said, they're, oh, sorry, it looks like people aren't seeing my slides, so I will, sorry. People are seeing that now. Just maybe tell me, somebody tell me if you're seeing NZ checklists now. Okay, I'll try. I'll try again. My Zoom just dropped out there for some reason, so let's have one more go at that. Hopefully you're seeing that now. Anyway, maybe let's see if somebody can pop that into the chat. Yes, good. We're back. Success. So there's the Austroads ones. There are still the New Zealand checklists available in the 2013 document, page 43 to 53. No, there were no wombats on those other pages. No, there weren't. In fact, I can just go back to make sure. It's just pointing you at some snips of the Austroads guide. So you haven't missed any wombats, but very good. Wally wasn't hiding in those. I just wanted to say that there are the checklists for the New Zealand ones available. So you've got lots of things that you could use to help spark ideas and spark thinking. But just remember, they're thought starters only. Look back at the holistic scheme, and there'll be things that aren't in the checklist potentially. Now, you do not submit any of this with your road safety audit. So these are just for you, for your use in the background when you're auditing. So this is in real audits. You don't submit the prompt list or the checklist with ticks and crosses and notes and everything like that. You just write up the issues that have come out of that. That's all for you in the background. Okay, so your assignment now is going to be, as mentioned, to do a little bit of practice identifying potential road safety issues from a design, and then practicing that writing up and using the New Zealand template for that. So what we've got for you is a functional design that has been prepared here, preliminary / functional design. And what it is it's the existing road has a roundabout at this intersection. It's a bit of an oval shaped roundabout, but existing roundabout. So you can see that in the green underneath. The design, what they're going to change it to is a large signalized intersection. So you've got 2 right turn lanes here. You've got some slip lanes coming out of this, and Yeah, you've got some bus stops. So things will change to that signalised intersection. So what you're going to be asked to do is to undertake the road safety audit, identify in the designs, so what they're planning to build, what are the crashes that could happen once this is all built, and then go through the process of, you know, writing what the crash is and the risk factors and severity. So you'll get 3 pages of the design. So you'll get the lead in there, and then you'll get the lead in from the other side, and you'll get the actual intersection itself. So you've got to be looking at this design, and as we practice a little bit, put yourself in the shoes of different road users, be it a pedestrian trying to cross, or a driver doing a right turn or a left turn, or somebody or the bus stopping, or whatever it is, and trying to say, okay, that could happen. Is this going to be an issue? Now, you are not going to be able to undertake a site visit, because this one, we just want you to practice. When you do those site visits, you're really looking and imagining it built at the existing site. But what we've done is provided you with some video footage of each of the existing sites. So hopefully I can just show you here. If I click on one of these, what you'll get, see if this actually works. Yep, okay. So hopefully now you're seeing on screen, when you click on wherever it is on that, you'll be given that PDF. You can get that spot, and you can have a look around that the existing conditions. You just you use your mouse to scroll around, look up and down, and you can see how the existing conditions, what the existing conditions are like. So that might help you in undertaking your audit, trying to identify issues with the future there. So you can click on any of those, and you will be dropped into that to be able to do a little bit of 360-degree looking at that site. So you'll be provided that as a PDF. You'll also be given a Word version of this, and this is what you'll be filling out. And I'm going to take you to that shortly, but you've got instructions on the first page. It's all about instructions. This is what your assignment is. You have an example from a different site, but an example of what we'd sort of expect to see, and then you'll be asked to fill those out. So I'm just going to stop sharing there, and I'm going to bring up Moodle. And share screen. Please, again, if I'm just sharing my screen now, you should be seeing Moodle. If you're not seeing that, please type in. Yep, good, we're seeing, thanks, Nick. Okay, so this is in module 3 now. You can see there, you've got the slides from Ferg, these last slides that I did that weren't hidden from students because we're not doing construction sites in this one. You have a quiz to do on Ferg's topic there, and then you click on the writing up audit findings. So it's really about practicing writing up these findings. You can see there, you've got the Word document, you've got the functional design, and you've got the PDF there. So I'll click on the Word document there and show you what comes up. And you can see here, you've got the Word document. These 2 things are attached, the functional design and your 360-degree, if you want to do your little fake site visit and the like. So review the design, review the 360 footage as you like, find two road safety audit issues with the proposal, not what's existing unless it sort of carries through. Write those 2 up using the template on pages 3 and 4 of this document. risk rate the issues, make recommendations, and categorize those, PDF it and upload it to Moodle. If you don't PDF it, that's okay. It's just easier to look at when it's PDF, but that's right. I put in some tips there to try to really make sure you're, really giving yourself the best opportunity to get a good mark. The last tip here, if you cannot find 2 issues, get in contact with somebody here, myself or Kathy or others, and we'll give you a few hints. You've got your risk rating matrix, which you'll be using. And then you can see here this example. So example, not from this design, from another one, but just to show you. And you'll be using the New Zealand template here, but you can see you sort of title the issue, the risk rating goes in there, you've got the description, remember that formula that we talked about, the issue, the crash that could happen, the factors that increase or decrease risk, any standards or guidelines that are applicable, and then you make a recommendation and you put a safe system supporting or primary with that. Down here is where the risk is sort of created. I'll show you, here's what you'll see. Yellow highlighting is what you're going to fill out. And you can see here after you've written that in, put a snip, hopefully, you make the that there. You've got a little drop down in the New Zealand ones where you can say common and unlikely to result in death or serious injury. And then you would put a risk rating through there and you'd go back to your 1 to see common, and what I say unlikely would be moderate. So that would be, and you write the information there. And you only do 2 findings. You do more than 2, because I'm sure many of you will find more than 2. They won't be read. You will just read the first 2 and mark those. So don't waste your time doing more than 2, because yeah, we won't read those. So as I say, you're trying to work this out. What are some of the issues when they build that in this functional design? So put yourself in the shoes of a pedestrian trying to cross. Where did they cross in the past? And where are they going to cross now? Ferg talked about some of the design issues, swept paths, stand-up angles, sight distance to areas, and the like. So think broadly like that from a technical perspective, but also think at a bigger picture level about pedestrian desire lines. Where are they? Where do they want to go? Is that clear? Are they going to just cross in other areas? Have we catered for people getting to public transport, getting on and off public transport? Are we providing all these features that are going to be nice and safe? You really won't have as much information as you would like. As I mentioned, you don't get the swept paths. You're not getting much information about speed, travel speeds, traffic modeling, drainage, lighting, anything like that. I want you to do the best you can with what you've got. It's going to be a 60 km/h speed limit, I think. I think that might actually be in this. 70 km/h speed limit, and they're keeping that, and 60 up on the side road. So you've got a bit of information in there. Lisa's asked a question: if you don't have swept path information, can you do it yourselves? Good question. I'd say that you don't need to go to that effort. We won't be providing you with the CAD version of this, just the PDF. So you may be able to overlay. You might just, if you want to make an assumption on something, you won't be marked down for it. Like if you assume the swept path won't work by just looking at it, we'll be fine for you to say, the swept path through here will encroach on the vehicles, maybe just put in brackets or something like assumed for exercise or something like that. I don't want you to be spending many hours doing this. I want you to sort of quickly identify a couple of issues and write them up. And it's really practice on, well, we do want you to practice identifying things out of a design and being able to look at a design and say, okay, the black lines are the new civil lines and the green is the existing condition. So if you're not somebody who reads sort of designs a lot, you've got to get a bit of a feel for that. But we really want to ensure that you're writing an issue up properly. So then, as per before, you're going to take this and you're going to see something slightly different. This is what I'm seeing, but you're going to upload it. There's a nice little upload box there. And yeah, so you want to try to do this week, ideally before next session. We can have a talk about it. I'll probably have a little chat about some of the issues. But ideally try and get onto it pretty quickly, because this is your one to practice writing that up before you go out to do your actual road safety audit, because it's the same thing. You'll be using basically the same template and looking at a design and looking at one live. So just want you to go through a bit of that, but just 2 issues, okay? 2 issues written up well. Any other questions on that? Okay. Well, thank you. It's been a wonderful session. It was good to have Ferg along. Yes, thank you, Andy. Yes, Ferg gets passionate about his road safety auditing. But thank you very much, everybody. I look forward to seeing you a little bit before the next session with chance to win a prize, and we'll have Kathy back then. Thanks, everyone. Good luck with your desktop auditing. Of course, get in contact with me if you struggle to find the issues or if you're struggling to write things down. Okay, bye.